Alright, so this worksheet, I'm just quickly review the polarity of the molecules worksheet. Now, this worksheet can tell whether a molecule can be dissolved in water by determining if the molecule are polar or not. So in order to determine if the molecule is polar, okay, so you must have two criteria. One is it will have polar covalent bond, like the delta En is 0.5 to actually 0.5 to 1.7, or it's greater than 1.7 no matter. And also make sure that the shape is not symmetrical, so that the dipoles are not cancelled. So we're going to explain on the bottom. Now there are three steps here. So the first step is if the bonds are polar or non-polar. So we have to tell if the bonds are polar or non-polar. So the bonds are polar if the delta En is 0.5 and 1.7, or if it's greater than 1.7 and no matter. Okay, so we will draw the dipole. And if that's the case, okay, the delta En is 0.5 or more, and we're going to draw the dipole, we draw this symbol. And the bond is non-polar if the delta En is pretty much less than 0.5, so then we will not draw the dipole, we will not have the symbol. So after the bonds, we're going to determine the whole molecule. Now we're going to determine the molecule is polar or non-polar. So if the molecule is polar, you will have polar bonds, and if the dipoles are not cancel each other. So what does that mean is if you have the dipoles, I have the dipoles, and the dipoles are not cancelled. So for example, see, I do have dipoles, but these dipoles are not cancelled because this dipole is bigger than that, even though the shape are symmetrical. So I do have finally a final winner, which is go to the right hand side, because the right hand side dipole is not cancelled by the left dipole due to the fact that the right hand side dipole is bigger. Or if I have one single direction dipole, go to the right or go to the left, and then I will have the dipoles are not cancelled. Or if I have two dipoles, go to like a V shape, okay, it's not cancelled. Or I have a V shape, and then I have the dipole from the leftover electrons on the central atom. So then this green and the red, they are not the same kind of dipole. See, this red is the dipole from the delta En. This green dipole is come from leftover around central. They are not the same kind. So even though these three are like a Y shape, they are not cancelled because the green are not the same string as the red. So even there's a Y shape, they are not symmetrical, so it's not going to be cancelled. So then when we go back to the polar bond, the polar molecule is we have a polar bond and the dipoles are not cancelled. And the molecule is non-polar if you have no polar bond at all. So that means I don't even have a dipole, not at all. No dipole, meaning that I don't even have a winner. A molecule is non-polar if they are polar bonds. I do draw the arrow, but they are cancel each other. So if they cancel each other, would be some kind of like this kind of the string, based on the fact that they have the same strength of the dipole, like same delta En. For example, these two have the same delta En. They on left and right, they cancel each other. Or top and bottom, they cancel each other. Or Y shape, they cancel each other. Or like a cross, they cancel each other. Or like, they're on opposite direction and they cancel each other. But based on the fact that they are the same strength, that means the same kind of the dipole, then they will be cancelled. And then if they cancel, will be non-polar. Or this, the situation D is the molecule is polar if there's a dipole because of the leftover electron on the central atom, which is this, okay? This situation is no matter you have the dipole on the red or not, no matter you have the dipole on the red or not, as long as I have a dipole from the leftover electrons on the central, I will still have a winner. Because if you have no dipole, just this green thing, of course, I have a winner. Even though, I just explained, even though I have the two red thing, but these two red things are not the same as the green dipole because this green dipole is coming from leftover electron and central. So then these three are not the same, so then they will be still cancelled. So if you have a dipole because of the leftover electron and central, you will still become polar because you have a winner. Now, how do I know the dipoles are cancelled? Okay, so I just explained. If the shape are symmetrical, like these shapes, then the dipoles are cancelled, will be non-polar molecule because no winner. If a non-symmetrical shape, so just like this kind of non-symmetrical shapes, the dipoles are not cancelled, then will become a polar molecule. And then finally, I can tell if the molecule dissolve in water or not. The molecule dissolve in water if the molecule is polar molecule. Right? If the molecule is polar molecule, it will dissolve in water because water itself is actually also polar. Water itself is also polar. Now we have a policy: is polar like polar, non-polar like non-polar. So if a molecule is a polar molecule, it will dissolve in water because water is polar. And if the molecule is non-polar molecule, it will not dissolve in water. Okay. So in this front page, I will first ask you to find out the delta EN for the element. So I found the C, I found the F. Now you don't need to find out all the F because they have the same thing. So I just need to find per one molecule, for one element. So you do the math yourself, okay? The delta EN between C and F is 2.5 minus 4.0, and you take absolute value, so which is 1.5. So 1.5, you have to draw a dipole because 1.5 is bigger than 0.5. Okay, so it's also like between 0.5 to 1.7. So I do have to draw a dipole. Now the next thing is, where should I draw the dipole? From C to F or from F to C? Should be from C to F because the dipole always drawn from small en to big En. So from C to F, not from F to C, because C is smaller, F is bigger. So I gotta draw like 1, 2, 3, and 4. Okay, now whether they connect to each other, it doesn't matter. So as long as I can see, one up, top, bottom, left, right. Now you can tell, number one, the bonds, I have 4 polar bonds because I can draw 4 dipoles. So then the dipoles, what happen? Actually, the dipoles cancel. This and this, same string and opposite direction, cancel. This and this, same string, opposite direction, cancel. So then the dipoles are all cancel. Now because they all cancel, I have no winner. No winner, non-polar. Because the molecule is non-polar, so it's not dissolved in water. The next question, you do the math. C to H is, the difference is 0.4. So 0.4 is not bigger than 0.5. So we don't draw the dipole between C and H. But C and Cl is 2.5 to 3. So it's like 0.5 difference. So we have to draw a dipole from C to Cl. C to Cl, C to Cl. But C to H, no dipole. Okay, so in this case, I do have 3 polar bond. 3 polar bond. 1, 2, 3. 3 dipole, 3 polar bond. And 1 non-polar bond. The non-polar bond, which is the CH. Okay, 3 polar bond, 1, 2, 3, and 1 non-polar bond. I do have 4 bonds. 1, 2, 3, 4. So 3 of them is polar. 3 of them are polar. 1 non-polar. So then you can tell, these 2 dipoles, left and right, they are cancelled because same string, opposite direction. But the bottom on the one on the bottom is not cancelled from with the top because the top one has no dipole. So